Hi Year 11, this is your walkthrough of your exam paper homework. Looking at the paper here, just please do make sure you've got the correct video. This paper is from the 14th of June 2013 and it's Unit 2. If in doubt, check the paper reference there just to make sure that you have got the correct one. So I'm going to go to the front cover here and also the formula sheet. Now, you might need that later, so don't bin it, but I'm just going to put it to one side, and of course you know that comes with every single one of your exam papers. We're going to start off with question 1. So question 1 is asking you to find the cost of a theme park ticket, which has been increased because it says plus by 20% for VAT. So the theme park tickets cost £35 plus 20% VAT. So what I'm going to do to be able to work that out, and this is a non-calculator paper, remember. So in order to work that out without a calculator, the easiest thing for me to do, first of all, is to find 10%. So 10% of the £35. And that is going to be £3.50. Therefore, 20% of £35 is going to be twice that, which is £7. Now, in order to get 3 marks on the question, it's not going to be enough just to find out what 20% is. I've got to work out the total cost of the ticket. Therefore, I'm going to have to do 35 plus the 7, which is 42, to give me an answer of £42. Now, you should be marking this in red pen once you've completed it, so you'll get your first mark for any correct method to find 20%. There. You get another mark by increasing, so adding it on, and then you get an accuracy mark for getting your final answer of 42. So now moving on to question 2. It's asking you to simplify the following expression because it's got no equal sign in it. So in order to simplify this, I'm going to start by identifying all of my different terms. So I've got a 2a there, a plus 4b, a plus 3a, and a minus b. And all I'm doing there is just identifying them so I can collect the like terms. So I add my a's up together to give me 5a altogether, and my b's, 4b, take away b, is going to be positive 3b. Now you'll get 1 mark for either of these being correct. So if you have just one of them, either 5a or 3b, you would get 1 mark. And then for your correct answer, you get a mark for that as well, so an accuracy mark for correct answer. Part B asks you to expand. What we need to do then is multiply everything inside the bracket by this number on the outside, by the 5. So I need to do 5 times m, which is 5m, and 5 times 2, which is positive there, so it's going to give me plus 10. That's just 1 mark, so it's 1 mark for correct answer there. And then finally, we've got some algebra there with indices. A to the power of 5 times by a to the power of 4. And there's a rule that we need to use here that if the bases are the same, in this case a, and it's a multiplication, we add the powers. So the answer is simply a to the power of 5 plus 4, which is 9. And again, that's just a mark for the correct answer for that one. So turning over the page then to question 3. So question 3 says there are 20 counters in a blue bag. In a bag, sorry, not a blue bag. The counters are blue, red or yellow. And then it tells us that 35% of the counters are blue, a fifth of them are red, and it wants you to work out how many yellow counters there are in the bag. So let's start with 25% then. 35%. So we'll need to find 35% of the 200 counters. Well, just like we did before, it's easy enough for us to find out what 10% is. So we can find 10%, which is 20, and 5%, which would be 10. So I would need 3 lots of 20 to make 30% in total. So 30% would be 60. Add them together, I can see that I would have 70 blue. So I'll find there's 70 blue. Then I need to find a fifth of them, which are red. So I want to find 1/5 of 200. Now what that means is divide 200 by 5 and times by 1. So 200 divided by 5. So if I was to do, don't go in, so I'm going to carry that for 0. So I know that red is 40. So altogether, blue and red would be 70 add 40, which is 110. So I know there's 200 altogether, so yellow then must be 90. So yellow equals 90, because 90 add 110 is 200. Now then, there's lots of different ways you could do this. You could have changed this here into a percentage if you had wanted to, and said that that's 20. And maybe you might have found that easier, and then you would have got the same answer. 10% is 20, so 20% is 40. Whichever way you went around it, you would get the marks as follows. So if you have found a correct method for finding the 70, you would pick up a mark there. A correct way of finding the 40 for red, you'd get a mark. By adding them together to find the difference, or taking them both away, whichever way you did it is fine, you would get a mark. And then of course for the correct answer you would get a mark, and that's how you would get the 4. So it is a little bit tricky to mark, but you should be able to have a look at how much you would get there, hopefully. So let's have a look now at question 4. So there's first 5 terms in an arithmetic sequence. Now, as soon as you see that word, arithmetic, you know that it's adding to go from one term to the next. So this is one of the simpler nth term rules that we can find, and we've got to find what this common difference, or what are we adding each time. So between 1 and 5 there's 4, and I'm just going to check that it works all the way through, and it does. So I'm adding on 4 each time. So this is essentially the 4 times table. It's just been shifted up and down a little bit. So we use that common difference of 4 and put that next to n, 4n. But then you've got to look at it and think, well, for my first term, it's not 4 though, so what do I need to do to get down to 1? Well, I take away 3. So my answer is 4n, take away 3, from finding that common difference. So you get 1 mark for each of these parts of the nth term rule, for either 4n or a 3. Now underneath it asks you about the nth term from a different number sequence is 3n squared plus 7. And it asks you to find the 10th term in this sequence. Now the 10th term, all that means is in that case n equals 10. So I need to substitute 10 into this expression. So I have 3 times 10 squared, that's this bit here, add 7. So that's 3 times 100, add 7, 307. So if you've shown that you've substituted that in to the expression, you'll pick up a mark, and then of course you'll get a mark for the correct answer there as well. So it's 1 mark for substituting and 1 mark for correct answer. So question 5. It should be looking really familiar in terms of how it's laid out to you now. So there are ingredients for making 16, and I'm just going to circle that just to show myself where it is, because I know I'm going to need that information. Chocolate biscuits. And it talks about Sabrina, who has some ingredients, and they're all listed there for you, some butter, custard, sugar, flour and cocoa. And she wants to know what the greatest number of chocolate biscuits is that she can bake. Now, first of all, there are a number of different ways that you can do this. Okay, we are going to be thinking about maybe what's the simplest way, possibly, that you could do it. So I'm going to have a look now properly and see how I might do it. Now, I'm just going to move that up so you can see my writing. So if I've got 16 chocolate biscuits, let's start with butter. Like I said, there are other ways of doing it, but I'm going to do it this way. So butter then, she's got 250 grams of butter. Okay, and it takes 100 grams to make 16. So we know that 100 grams equals 16 biscuits. So in that case, we could have a look and see, well, she can make 1 lot, 2 lots and a half. So she can make 2.5 lots of the 16 biscuits. 2.5 times 16, or you can use a lattice method for this if you want to. So I'm going to do 2.5 times 16, because this is a non-calculator paper, to give me 30. So that's 30 biscuits she can make with this amount of butter. Okay, so now we've got the sugar. Now this one's a bit easier. She's got 300 grams of sugar. She needs 50 grams to make 16 biscuits. Well, that's quite straightforward. She can make 6 lots, so you do 16 times 6. Well, already I know that this is going to be more than the butter, isn't it? This is going to be more than the butter that she's going to be able to make. So I immediately know that this is now higher than this. So I don't really need to work this out. But if I did, it would be 96. So it's considerably higher. So we know that we're not going to be able to make 96. We're kind of at 30. So then flour. We've got 600 grams. And we know that 120 grams is how many she needs for 16 biscuits. So again, we can have a look and see how many lots of 120 go into 600. So 120 into 600, which is the same as doing 12 into 60. So that would be 5 lots that can be made. So again, I know that that's too big because I've only got enough butter to make 30 biscuits. So I know that that's not going to be correct. So I'm going to say that one's wrong as well. Now I'm going to look at my cocoa. So 15 grams, I've got 60 grams and 15 grams gives me 16 biscuits. Well, I know that 15 times 4 is 60, so I can get 4 lots of the 16 biscuits. So I can do 4 times 16, which is 64. So again, 64 biscuits, that's going to be too many. So it looks as if it's going to be 30 biscuits. I'm just going to check my maths on that. So 2.5 times, because it looks a little bit wrong to me. So let me have a look at this up here. So having a look at it again, let's do 2.5 times. It looks like I've probably not carried something here. And yeah, if I look at my lattice method, there is a mistake. So I'm going to put that right now. The reason I've noticed that is because I've looked at the difference between these and I've seen that it doesn't look quite correct. So I'm going to do my lattice method again, just to double check it to make sure it's correct. Because I think when I've added it round, I haven't carried. So let's write this back out, 02 and 12. So now I've got 0, 10, carry up. That's where my mistake was. It is actually 40 biscuits that can be made. These are all still way too high, so my answer is 40. Now there are a number of different ways that you can go about this, but I'll just talk you through the marks there. So as long as you have found a method of working out how many biscuits there are, you'll get 2 marks for that, so M1 and M1. Then you get another mark for working out what's left over, so this, and then you get an accuracy mark for your answer, which is 40. So just be careful on your lattice method and make sure that you look that up if you're not sure how to do it. Now the next question then is asking you to draw a graph. Now you're not given a table, which is quite unusual. Quite often you're given a table for this in order to fill in. But it does give you values that you need to use. So the first thing that I'm going to do is draw a table. So I've got my x value and my y value, and the values they want me to use are -2 all the way up to 3. So in order to draw a linear graph, this is a straight line graph, we haven't got a squared or anything like that. We only really need 3 points, but we do, out of completeness we can do more than that, but you could do any of these points here, but it does expect you to draw the graph completely through these values of -2 to 3, so it makes sense to have those in there. So now I'm going to substitute in to this equation. So 2 times -2 is -4, minus another 1, that's -5. 2 times -1 is -2, minus another 1 is -3. And we should have -1, 1, 3, and 5. Now what we need to do is draw that onto the graph paper that's provided for you. Now there are other ways of plotting graphs using the gradient if you wanted to. I'm just going to go through this one though and carefully draw a line graph then. So from -2, this is your x-axis, so across and down, got a mark there, -1, -3, 0, -1, 1, 1, 2, 3, and 3, 5. And then you need to join those together beautifully to show that you've got a perfect straight line graph. So using a ruler, making sure that you're absolutely going through the -2 to 3 like you've been asked to. Now if you've got a couple of correct points there, you'd get 1 mark. You'd get another mark for attempting to attempting to plot these points. And so your final mark is for that straight line that goes from -2 to 3. So that's 1 for some points, 1 for actually plotting them here, and 1 for the line. So your next question is about Terry filling up a carton with boxes. Each box is a cube, so that's quite important. So straight away we need to know a little bit of something about cube. So Terry fills the carton with boxes, and the size of that box is 10 by 10 by 10. Gives you some information about this cube as well, saying the length, width and height of it that are also on the diagram. So it works out the number of boxes that Terry can put into that big carton. So you can think about this in a number of different ways. However, probably the easiest way is to think that this box here is going to fit along this side a number of times. Now if that's 10 centimetres along, I should be able to fit it 6 times. So you can start out by saying that 60 divided by 10 equals 6. So I know I can fit 6 boxes along the bottom of that cuboid, Now again, I can work out how many go along the back here. So 50 over 10 would be 5, so I can fit 5 here, 6 here, and upwards I'm going to be able to fit 3 because 30 over 10 is 3. So that's the number of boxes that I can put just along each side. So that's one way to think about it. So that means it's 6 by 5 by 3. And if I multiply those together, 6 times 5 is 30, 30 times 3 is 90. I can fit 90 cubes within that cuboid. So my answer is going to be 90. So I get a mark for these divisions, a mark for the multiplication, so it's to show some, and it doesn't matter if you've done it here or later on, a division and a multiplication in this context would get you those 2 marks. And then finally, as always, you've got a mark for the correct answer there. Question 8's got a little star by the question number, so we know that it's going to ask for some superb communication here. And this is a diagram of a floor plan of a dining room. We're going to cover the floor with wooden floorboards, sold in packs of 2.25 square metres. So the first thing I'm going to need to do is work out the area of the floor just here. So you can do that a number of different ways. I'm going to think about splitting it along here into 2 different rectangles, which I've called A and B. Now, I've just clearly labelled those so that the examiner knows exactly what I'm talking about. And likewise, I'm going to very clearly show that I know that this here is 2 metres and that this here is 2 metres. So I'm just being very clear that I know exactly what those lengths are. So, let's start. And because we've got this star by the question, we want to make sure the communication is very, very clear. We're showing all of our workings. So we're going to say in A, the area is 2 times 4.5 metres. So that would be 9 metres squared. For B, the area is going to be 2 times 3, 2 times 3, which is 6 metres squared. So my total area is going to be 6 add 9, which is 15 metres squared. So that's the first thing that I'm going to do. So that shows me then what the complete area of floor is that I need to use. But now I'm going to see how many packs I'm going to need to put in. So I'm going to do 15 divided by the area that the pack will cover. So it's going to have to be 15 divided by 2.25. So we're going to need to work out how we're going to do that. Now, of course, you can try it by multiplication, by division. You could try it by addition if you wanted to. One of the ways that you could think about it is that 10 times 2.25, I would just move that decimal point across one place. So I know that that is 22.5. So I know that it's less than 10. I know that it's less than 10. If I want to use multiplication then to do it, I'm going to be better off starting below 10, and you could pick any number to start with. I'm going to start with 7. That's because I think 9, well, if I take 2.25 off 9, it's going to be 20, isn't it? And then 8, so I'm going to try 7. So that is going to be 2 times 7 is 14. So it's going to be 15.75. So it does seem very, very close indeed. So that's a good first guess. I'm going to be sure that then there's 6 2.25s that go into 15, but there is going to be some form of remainder there. And because I need enough flooring to cover my floor, if there's any kind of remainder, then I'm going to need to round up. But just for completeness, we'll complete off and see exactly what this answer is. So I'm going to do the 2.25 times 6. So 13.5. And then I'm going to carry over my remainder here of 15 again. So it looks like we're going to have a recurring number of 6.6 recurring happening here. So I'm going to round that up. So I'm going to say I need 7 packs, because obviously I'm going to need more than is required there. So in order to mark this then, one mark for one of these areas, and then another mark for this complete area. One mark for showing somewhere 15 divided by 2.25, and then a final mark for your very clear explanation that you need the 7 packs. So now we're on to question 9. Question 9 is asking you for the volume of a triangular prism. Now, the volume of a prism is actually fairly straightforward, so you shouldn't have too much problems in being able to work this out. However, there is a common error that comes up when people do this, especially with the triangular prism. The volume of a prism is given to you on the formula page, area of a cross-section times by the length. So I need to find the area of the cross-section to begin with, and this here is my cross-section. It's a right-angled triangle, so I'm going to have to do half times the base times by the height. That's the first calculation that I would have, and that is going to be 30 centimetres square. Once I've found the area of the cross-section, I find the volume by multiplying it by how far that's pushed back. So if you think of this being replicated over and over again, this cross-section, so I do 30 times by 10, which gives me 300 centimetres cubed. So my answer is 300. And in terms of marks, there's just 2 marks for this. 1 mark for your working and 1 mark for your correct answer. Question 10. So question 10, it tells me that these are 2 regular pentagons. They're quite hard to see, actually. If you consider this is 1 pentagon here, so I'm going to just colour that one in green. So that's pentagon number 1. And here is pentagon number 2. So these are my 2 pentagons. So they're regular, which means all the sides and the angles are the same, and these are the same size. Work out the size of angle EAH. And we must show how we got our answer. So, first of all, you can think about how to find the interior angle of a polygon. So, there's a couple of ways in which you can do this. However, the simplest way is to take the number of sides, which is 5. So I've got 5 sides. And I take away 2, which gives me 3. And I just times 3 by 180, which gives me 540 degrees. That will give me the sum of all of these angles. So if that's for the 5 angles altogether, that's the total. I'm going to have to do 540 divided by 5, which is 108 degrees, to give me the size of every single one of these individual angles. So this here will be 108 degrees. And likewise, this here will be 108 degrees because of those 2 separate pentagons. So I know what my interior angles are then. So now I can have a look and think, what could I do next? So, I'm looking for angle HAE. I know that angle EAB is 108 degrees because I've already worked that out here, EAB. So I know that this here is 108 degrees. So now I'm going to think about how I find this here. Well, I know that this here is 108 degrees and this here is 108 degrees. And I've got a quadrilateral, so the interior angles of a quadrilateral equals 360 degrees. So if I do 360, take away the 108, take away the 108, and divide that by 2, that should give me the value of this angle here, HAB. So, in order to do that, I could add these 2 both together. So 108, add 108, is 216, and then take those away. So 144. Now I can go ahead and have a look and see how this is going to affect my angles. So 144 over 2, sorry. This is going to be 72 degrees. So if this here is 72 degrees in here, then this angle here is going to be 108, take away 72, which is 36 degrees. So my answer is 36 degrees. So in terms of marks then, again, a number of different ways you could do it. You can get 1 mark here for recognising 108. And that can be marked on your diagram. You can get a mark here for correctly having a method of how to find this angle here, and a mark for correctly finding that angle, and then finally an accuracy mark for your correct answer. So that's for question 10. It's quite a tricky one. Do see a teacher if you find that one hard, because it is one worth knowing. So have a look at that one again if you need to. So just put the working across there a minute so it's out of camera. Okay, so that's where your marks come from. So on to question 11. So the distance from Caxby to Drone is 45 miles and the distance from Drone to Elton is 20 miles. So, Colin drives from Caxby to Drone, which we know is 45 miles, and then from Drone to Elton. He drives from Caxby to Drone an average speed of 30 miles per hour. Now that's key information, so I'm going to write it up here so that I have got a diagram of what's happened. He then drives from Drone to Elton at average speed of 40 miles per hour. Work out his average speed for the whole journey. So, what we need to do then, we know that speed is distance over time. So in order to find that average speed, I'm going to need to know the total distance and the total time. Now the distance is quite simple because I've been given 45 and the 20, so that's going to be 65 miles. And now I'm going to have to work out the time. So if I've got the speed, so I can use one of these conversion triangles if I want to. So speed is distance over time. So if I've got the speed, but I want to find the time, say that time is distance divided by speed. So I'm going to need to do 45 divided by 30, which is 1.5, and 20 divided by 40, which is 0.5. So my total time then is 2 hours. So then I can go ahead and work out my speed. So if I've now got my distance and my time is 2 hours, speed is distance over time, so 65 divided by 2, which is going to be 32.5. So my answer is 32.5. Now in order to mark that, we can have a look. The 3 marks are allocated so that you get 1 mark if you're shown somewhere that you're doing this division here, or this division here, so this will give you 1 mark. So that gets you a mark. And then you get another mark for finding the time, so for actually working out that it's 2 hours, and then of course you get a mark for the correct answer in the end. Question 12 is asking you to simplify, so we will need to have a look and see how we can go about simplifying that question. We've got 2 different expressions with brackets around them, and we're going to need to look at how we expand them. Okay, so what we're going to have a look at then is how to simplify the question. So the first thing we need to do is consider what this squared notation means. Now, common error is to think that means x times x and 5 times 5, but it doesn't. It is the whole expression within the bracket that's squared. So this becomes x plus 5 times x plus 5. And this becomes x minus 5, x minus 5. Then we need to expand those brackets now. You might feel comfortable using FOIL. You might rather use a grid method. I'll use FOIL for these. So this is x squared plus 5x plus 5x plus 25. And I can simplify that to x squared plus 10x plus 25. So that's my first expansion that I've done. But then I need to bear in mind that it is minus. So I'm going to drop that minus sign down now and expand this. And I'm just going to put this expanded section in brackets here. So this is going to be x squared minus 5x minus 5x minus 5 times minus 5, which is a plus 25. Okay. So I've now managed to expand that. There's a little bit more that I need to do. So now I'm going to collect up my like terms, just being very careful about these negative signs. So this one I'd already collected up when I got to this point. So it's x squared plus 10x plus 25 minus x squared minus minus 5 minus minus 5. Well, those two together are minus 10. So this becomes minus 10x. but a minus and a minus is a plus, so this is going to be plus 10x. And I've got my 25, but it's minus 25. And now I'm going to consider my like terms. So, just like we did in the beginning of the paper, but with a more complex expression, I'm going to now look to collect up the like terms. So, I've got x squared minus x squared, so they've disappeared and cancelled each other out. I've got a plus 10x and a plus 10x, which gives me a plus 20x, and a plus 25 and a minus 25. Well, those two cancel themselves out as well. So my answer to that one is simply 20x. Now there are loads of things that can go wrong in that question. Common errors would be not expanding the brackets. Common errors would be complicated use of these signs here, so a minus and a minus and a minus and a plus. Now remember, if the signs are the same, they always are a positive. If the signs are different, they're a negative. And if you can apply that, then most questions like this you will be able to get right. So you get your first mark for expanding one of the brackets correctly and coming up with this. So this is your first mark. This here is your second mark, which would then lead you on to the correct answer. Yes, that's actually an accuracy mark there. So 1 mark for expansion, 1 mark for that correct answer. Not a lot of marks going there for quite a tricky question. So now on to question 13. Circle theorems. So circle theorems, popular on both papers. And straight away when I'm looking at this, I see a radius and a tangent. So immediately my brain is going to be thinking about that circle theorem before anything else. There's a star by that number, so I know my communication has got to be spot on. A and B are points on the circumference of a circle with centre O. AC and BC are tangents to that circle. AC and BC. Now before I do anything else, I'm going to mark this as a right angle and this as a right angle because I know it is. Okay? So that's the circle theorem that a tangent meets a radius at 90 degrees. Then it goes on to tell me angle ACB is 36 degrees. Find the size of angle OBA. Okay, so I've just got to think quite carefully about this now. OBA. So I need to draw another line actually, because it's not asking me for that 90-degree angle. OBA is this angle just here. So this is the angle that it's asking me to find. Okay. So the first thing that I'm going to write down is that I've noticed that OBC equals OAC and that they equal 90 degrees. And that is because a tangent meets a radius at 90 degrees. Okay. Now I'm going to have a look at triangle AOB. Now these two lines here are the same length. They're both radii. So the type of triangle this is an isosceles triangle. So triangle AOB is isosceles. And that's because two of the sides are radii. And that's just the plural for radius. Okay, so the angles in a triangle are going to be 180 degrees. So I'm going to know that these three are going to add up to 180. So it makes sense for me to try and find this angle here. So I've got a kite. And the kite is this shape here. The two radii and the two tangents. So I'm going to call the kite AOBC. So I'm just telling the examiner AOBC is that kite that I'm talking about. So that height, interior angles equal 360 degrees, and that's because it is a quadrilateral. Okay, so I know what three of the angles are. So if I do 360, take away 90, and take away 90, I'm going to be left with the total of these two angles, so I'll then need to take away the 36. 360 is the total take away the two 90-degree angles and then take away the 36 degrees. So that's okay, I feel like I can do that. So that is 144 degrees. So I can say that AOB, so angle AOB equals 144 degrees, as we've shown above. So now that I've got that, I can use it to work out what the angle is that I'm required to find. So I've already said about this triangle, so I'm going to say triangle AOB. So in triangle AOB, I can do 180, take away 144, will give me the total of the two angles, and then divide that by 2. So 180 take away 144, that is 36, divided by 2 is 18 degrees. And that is my interior angle of a triangle is 180 degrees. So 18 degrees is my answer. And in terms of marks, and there are a few different ways of doing it, if you've shown that these are 90 degrees, you get a mark for that. So a tangent meeting a radius at 90 degrees, you'll get a mark for. Then you're going to get another mark for a method to find out what one of these angles is. So the fact that it's divided by 2, you'll get a mark for that as well. Then you need your reasons. So you get a mark for one reason, and you get another mark for 4 reasons. So all that work that we've done, out of that 4 marks, 2 of them were for numbers and 2 of them, so 50% of the marks then, were related to the reasons that you've given. So now question 14. So question 14 is a cuboid on a 3D grid. Coordinates for vertex M. Coordinates of the vertex M here are 5, 3, 2. Okay? So 5 on X, 3 up and 2 out. Work out the coordinates from the midpoint of LN. So, the midpoint of LN. Let's just draw that in. So, the first thing that you're going to need to do is think about how you're going to be able to work out the midpoint. So, let's first of all think about the coordinates that we know. So, we know that M is 5, 3, 2. So if we know that, we should be able to work out L as well. So the x-axis here, L is at 0. Then we look at the y-axis, well that's up at 3 because it's in line with M. Then we look at how far it comes out on the z-axis, well it comes out to 2 there. So that's going to be my coordinates of L. Then I'm going to have a look at my coordinates of N. So for N then, N is going to be 5 on the x-axis. On the y-axis it's going to be 3, but on the z-axis it's going to be 0, because it doesn't come out on the z-axis. So now I've got my points for L and N. To find the midpoint, I simply have to add each of the x, the y and the z coordinates and divide them by 2. So we'll start with x, which will be 0 plus 5 over 2. So 0 and 5. Then I've got 3 and 3, so 3 plus 3 over 2. And 2 and 0. 2 plus 0 over 2. So my x coordinate is going to be 2.5, because that's 5 over 2. 6 over 2 is 3. 2 over 2 is going to be 1. So my coordinates are 2.5, 3 and 1. So your first mark in this question is for working out or showing that you have to add them together and divide by 2. That's your first mark. And then your second mark is for your correct answer. So again, just 2 marks for that question. But it's logic. You have to look at it logically and think, how can you work it out? It's not mathematically very challenging, but you have to try and get your head around it. So question 15. So question 15 is asking you to change a recurring decimal into a fraction. So this is something that you should become quite good at. So we're going to show every step here. So we're going to first of all say, we're going to let x equal 0.750, and those two are recurring numbers. Now, because 2 numbers are recurring, I times it by 10. If it was 3 numbers, it would be by 100, 4 numbers by 1,000. So 10x equals, so I just write down that 10x equals 7.505050. Of course, that's going to recur forever, but it becomes easier if you write down more than 1. Now, what I want to do is eliminate the recurring 50, so I want to get rid of that. So, in order to do that, I need to think about, how do I line this up so that I can get rid of it? Well, if I times it by 10, it's not in line. What if I times it by 10 and then 10 again? So I'm going to times it by 1,000 now. So that 1,000x is 750.505050, etc. Now that I've got that, I'm able to cancel out these recurring numbers. So if I do 750.50 recurring, so 750.50 recurring, and take away 7.50 recurring, these will cancel each other out, and I'll be left with 347. So I've done the 10,000, take away the 10. So this is now 990x equals 743. But I only want x on its own. I don't want 990 of them. So I'm going to divide that by 990. So my answer is 743 over 990. So it's all about lining up those recurring numbers, and once you've done that, it really does become quite straightforward. Okay, question 16. So I asked you to write down the equation of a straight line that's parallel to the straight line y equals 3x minus 5. Now, you can really have any value for the coefficient of x, for the constant here that you like. Because it's this constant, the minus 5, that fixes the graph. 3 is the gradient. And that says how steep it is. So as long as you've got the 3x, the y equals 3x, the bit that comes after it doesn't matter. Now, it can't be minus 5 because that would be the same. But let's go for 3x plus 6. Now, all that means is the graph of 3x is moved up by 6 instead of down by 6. So that's all that means. Straight line L is perpendicular to the straight line of 3x minus 5. So perpendicular means crosses at right angles. So I've got my line of y equals 3x minus 5, and this one is going to be absolutely perpendicular to it, or going the other way. So we need to think about, how do we know what a perpendicular line is? And also, it says that it passes through a certain point, 0.65. So the first thing that you're going to have to do on this question is firstly to understand what you need to do to make it perpendicular. So for it to go absolutely the opposite way, perfectly the opposite way, we're looking for a negative gradient instead. So this one is positive, and we're looking for a negative gradient instead. So that gradient would be minus 1 over 3. Now the other way you could put it is 3m equals minus 1, but it would be minus 1 over 3x. And then we're going to add something onto it in order to fix that line in the right place. And the way that we're going to figure that out is by using this point. So we substitute in the 6 and the 5. So we'll have x equals 6 and y equals 5. So we're going to say that 5 equals minus a third times 6 plus something. So 5 equals a negative third of 6. Okay, that seems okay. So a third of 6 is 2, so it's minus 2 plus something. Well, what do I do to minus 2 to get up to 5? Well, I add on 7, so C must equal 7. So my answer is y equals minus a third x plus 7. So for the whole question, this first one is just simply 1 mark for this first part. For the second part, your minus a half will get you your first mark. Then, showing that you've got to add on C somewhere, that would get you a second mark, and a final answer there for your third mark. Coming towards the end of the paper now. Question 17. Write down the value of 10 to the power of minus 1. So this is the point where no matter how hard you find the paper, it's definitely you've got to look right through to the end, because these aren't too bad now. So a negative indice, that's just the reciprocal. So instead of just 10 to the power of 1, which is 10, 10 to the power of negative 1 is just 1 over 10. And that's just 1 mark for correct answer there. Now for this next one here, 27 to the power of 2 over 3. This means 27 to the power of a third, or to the power of 2. So 27 to the power of a third is a cubed root of 27 to the power of 2, which is 3 to the power of 2, and so your answer is 9. So for that one, it is a couple of marks. Your first mark is for showing this here. So this is your first mark, and then you're going to get an accuracy mark for finding out that it's 9. And then we've got a third, the root of 75. It's asked you to write it in the form of k root 3. All that means is it wants you to simplify that third. So you've got to think about the fact that root 75 can be shown as the root of something times by root 3. So it's how many 3's go into 75? Well, 25 do. So the root of 75 will be the root of 25 times the root of 3, because these two numbers here have to add to this number here. Okay, so root of 25 is 5, so this is 5 root 3. And that is in the form of an integer and the irrational number, which is the root. So that's simply my answer. You get a mark for this, and you get a mark for that accurate final answer. Now this next question is about factorising, and it asks you to simplify 2x squared plus 6x all over x squared minus 2x minus 15. So when you see this, whenever there's an algebraic fraction, it's always factorising. So let's first of all factorise this and see where we get to. Common factor between the two is 2x, so I'm going to times that by x to get to 2x squared, and by 3 to get to plus 6x. Now this here is a quadratic, so I'm going to have to factorise it into two lots of brackets. I know that because it's a squared. X squared is the highest power. I've got minus 2x, I've got these three parts, and the integer at the end. So I know it's going to be an x in both brackets, but I've got to think of two numbers that I can multiply together to get a minus 15, but add together to get a minus 2. So the difference between them is going to have to be 2. So I'm thinking 3 times 5 here, and because I want a negative 2x, I'm going to need a minus 5 to add 3 on to get the minus 2. Now if I expand that, I can be perfectly sure that I'm right. So there's really no reason for this bit to be wrong ever in the exam, because you can check it yourself, and if you've got time and people tell you to check your paper, this is the kind of thing that they're talking about. So I've factorised the lower part of the fraction to give me x minus 5 x plus 3. Now remember, those can be written either way round. And here I've got a common factor, so if I cancel these, I'm left with just 2x over x minus 5. And that's going to be my final answer that I put into here. Now to finish off, I'm just going to tell you where the marks come from. So you're going to get a mark here for this factorising of the top, a mark here for factorising at the bottom, although these can be the other way round, so don't worry if they are, and then a final mark for your accurate answer. So please make sure that you mark your papers thoroughly and speak to your teachers if you need any help with any of the questions that you can't do. And good luck.